Our objective for this lesson is to use geometric sequences and series formulas to find the sequence or the series sum, or to use the information from a sequence or series to find the formula. Now, we first of all want to remind you that we've dealt with sequences before. We dealt with arithmetic sequences. Arithmetic sequences was where you added the same thing each time to get to the next term. A geometric sequence is where you multiply by a term, a common ratio, to get to the next term. So as an example, you'll see one down here that we'll get to in just a moment. This number 26 is your first term, and then from there you just double it. So you multiply by 2, you multiply by 2, you multiply by 2. You always multiply by that same ratio to get to the next term. To find that ratio, you can always take any of the two terms that are consecutive, take the second one, put it over the first, and you get your ratio. So let's go ahead and define the concept here. So a geometric sequence is where you multiply by the same ratio to get to the next term. Now, there's two ways we usually list these, two types of formulas we use. We use a recursive formula and an explicit formula. Recursive formula is where you define where you start and then how do you get to the next term, that idea of what a geometric sequence is. Explicit takes that formula and gives you a formula that allows you to jump to any term inside the sequence. So for recursive, you want to list the first term, and how to get to the next term. So as an example, if we're listing the formula here, again, it's a sequence is a list of numbers, so we would list it, for instance, as a sub 1, a sub 2, a sub 3, and you just keep going. So this would be a sub 1. In this sequence, we have a sub 1, a sub 2, a sub 3, a sub 4. So we're listing it as what number term you are in the sequence. So the recursive formula is where you just say any term in the sequence, a sub n, is going to be either the first term, which would be a sub 1 for n equal to 1, or you take the previous term to a sub n, that's a sub n minus 1, and you multiply by a common ratio. That number here would be multiplying by 2 each time when that n is greater than 1. So for the second, third, fourth term, you can use this to find what the next term is. So what we have here is that a sub 1 is the first term, and a sub n minus 1 is the previous term, and r is the common ratio. And how you find r is that you take any two terms. You take, for instance, a sub n and divide by its previous term to get that common ratio. Okay, so that's the recursive formula. Now the explicit formula is where you want to jump straight to a term. So jump to a term in the sequence by using a formula. That formula is usually defined by what number term do you want to get in the sequence. So when it comes to using this to get get the explicit formula, how we'd write that is the nth term is equal to the first term. You gotta define what the first term is. This sequence would be totally different if we started, let's say, at 10 and then doubled the numbers. So you gotta define what the first one is, and then you multiply it by r to the n minus 1 power. Now, it's n minus 1 because if you think about it, if we have the first term here, to get to the second, we multiply by 2 just one time. To get to the third term, we multiply by 2 to get here, and a second 2 to get there. It's always one less of the common ratios to get to the numbered term you're in, because we don't have to multiply by that common ratio to get to the first. So n minus 1 defines for us how many common ratios we multiply by. Again, a sub 1 here is my initial number, initial term, so the beginning term for it. Okay, now let's go ahead and work with this, and sometimes we might just list this as an A, as we do sometimes in our interest rate formulas instead of a sub 1. All right, let's go ahead and work with this now. On this one, let's go ahead and do the work on this example. So for this one, I want to find the common ratio first. So to find the common ratio, I'm going to take any two terms. You can pick your term, and I'm going to, for instance, I could take 208 and divide by the previous term, 104. And when I divide that, that gets me my common ratio of 2. So if I'm listing my recursive formula here, my recursive formula is going to be a sub n equals, you define the first term is 26 for n equal to 1, and then you're going to find the next one, you take the previous term, a sub n minus 1, times the common ratio for n is greater than 1. Notice that the only thing that changes here, what we have to fill in for this formula will be exactly the same each time, except you have to fill in the first term and you got to fill in that common ratio. So that's the two pieces that change, otherwise the formula is the same. Now for our explicit formula, that's going to be a sub n equals, and notice you start at the first term, so it's going to be 26 plus, times, so we're multiplying by it, so times the r common ratio, and in this case that common ratio is a 2, and we put it to the n minus 1 power. So let's say I wanted to find the next term in this sequence. If I wanted to find what a sub 5 is, if I wanted to find a sub 5 from this formula, I'd just take a sub 4, the term previous to it, multiply it by 2, so that would give me 416. Or I could take this formula and put in, if I wanted to find a sub 5, put in 5 minus 1 is 4, 26 times 2 to the 4th would give me my next term as well. So using either will get me the final formula for that. So these are my two formulas for this example. All right, now the next example here, what it does is it gives us the information in the recursive formula, and let's say that we want to find a sub 13, the 13th term. Now you could start at 11, and this says multiply by 4, so that'd be 44 for the next term, and then multiply by 4 again, and you get 176, and we keep going. You could go all the way out to the 13th term, use the recursive formula for it. But it's usually quicker to jump to the 13th term by finding what the explicit formula is. So for this one, my common ratio is 4, so I'm going to have my recursive formula, my explicit formula be the first term, 11, times the common ratio, 4, to the n minus 1 power. So I pull off this number and this number from it, put it into my explicit formula. To find the 13th term, I'm going to do 11 times 4 to the 13 minus 1 power, which is 11 times 4 to the 12th power. And that's going to give me, when I do that calculation, I'm going to get 184,549,376 for an answer. So that's a way to jump to that term by using the explicit formula. Okay, let's go ahead now and talk about what a geometric series is. So that was a sequence. Sequence is when you list the numbers. A series is when you add those numbers up in the sequence. So the concept for geometric series, add the terms of a geometric sequence. All right, so for example, we want to use example 2 up here, so I'm going to make sure I can see example 2 here. I'm going to use this sequence up here. I'm going to add the first 3 terms. So if you think about it, there's my first 3 terms there. So what I would do is I would take here and take 11 plus 44 plus 176, and when I add those terms up, I'm going to get 231. So in this case, since it's only 3 terms, we can just list the 3 terms and then add them up to do that. Now let's talk about some formulas and notation for this. So first of all, we have a formula that allows us to add the first n terms. Like if you wanted to add the first 20 terms, it might be a little bulky to do this process out to the 20th and add them all up. So there's a formula that can help us with that. And so that formula, and this is for sum of n terms for a geometric series. And that formula is where we say S sub n, S standing for the sum of the first n terms. That's going to equal the first term, again, sometimes listed as a sub 1, sometimes just listed as a, times 1 minus r to the n power, all over 1 minus r, where r is our common ratio for it. So this formula allows us to find, for instance, if we're doing the first 3 terms here, we do S sub 3 is equal to the first term in the sequence, 11, times 1 minus, now I'm multiplying by 4 each time, notice that was my common ratio, 1 minus 4 to the 3rd power, all over 1 minus 4. So you put in the first term and the common ratio into that, and if you do that calculation on your calculator, you'll get the same 231. You could do that now for any number of terms in the sequence. So this is a handy formula to use, especially if you have to get many of the terms of the sequence added together. All right, lastly here, we want to reintroduce, because you may have seen this notation before, what's called summation notation. That's for when we want to add a certain number of any sequence or series. What you typically will do is you'll put in, this Greek letter sigma, and you want to list for it the important information. What usually goes here is you put, usually using one of the letters, like we'll use n. If you start at n equals 1, that's the first term I'd start at, and we're going to go up here to say to the 3rd term. This would just say I'm going to sum, this says sum the first 3 terms. Okay, so if I said 1 to 5, it sum the first 5 terms. Now what you put here as a formula in this is the explicit formula. So my explicit formula here is 11 times 4 to the n minus 1 power. So this is my explicit formula. And that gives me a new notation. So if you think about it, what this says is, let's put in 1 into this. So you're going to have 11 times 4 to the 1 minus 1 power, added 2, so this sum means add them together. Let's put in 2, count your way up to 3. So 11 times 4 to the 2 minus 1 power plus 11 times 4 to the 3 minus 1 power. So you count your way all from 1 up to 3, calculate each of those together, and you would get the 231. So the summation notation just gives us a way to write out how we're going to do the sum of each of the terms of the sequence. So a sequence is a list of numbers. A series is where you add those numbers together. With the sequence, we have two ways to list those formula-wise. We have an explicit formula, which allows us to jump to a term, or the recursive formula, where you define the first term in the sequence and then how we get to the next term. Then we talked about series, where you add those terms together, and if we want to, in a geometric series, add a certain number of terms, you can use this formula to jump to that sum rather than listing them all out and adding them together. And then we also can list it in summation notation, which allows us to look at the explicit formula and how the formula would lead you to adding up each of those terms of this sequence.